The human brain is already the most complex system in the known universe. But imagine a future where that complexity doesn't just define our limits, it expands them. A world where memory is no longer fragile, where learning a new language takes days instead of years, and where human intelligence itself can be dialed upward like adjusting the brightness on a screen. That's the promise and the peril of neural enhancements, the new frontier of brain technology. And here's where it gets fascinating. We're not talking about distant science fiction. Companies like Neuralink, Kernel, and Synchron are pushing implants and brain-computer interfaces from theory into reality, while university labs are discovering ways to amplify cognition itself. Stay with this story, because the numbers, the breakthroughs, and the human possibilities here might change the way you think about what it means to be intelligent. What once belonged to the realm of cyberpunk novels is now being tested in real clinics with real volunteers, in timelines that can be measured in years rather than centuries. Subscribe, like, and turn on notifications, because here on Tech Mythos, we break the silence around the technology shaping your future. Now, let's begin with a bold claim. Human memory could be doubled in accuracy and speed within the next 2 decades. That sounds outrageous, but peer-reviewed studies from DARPA-funded projects already show a 35% boost in memory recall using hippocampal stimulation. If military-funded implants can already achieve that much in lab tests, scaling to double over time isn't wild speculation, it's a trend line. The incremental progress of neuroscience tells us that when you can consistently improve memory recall by 1/3 in controlled conditions, a future doubling is not fantasy. It is engineering, refinement, and persistence. To understand why this matters, think of your brain as the original hard drive. Every memory is a file. Every thought is a program. But unlike computers, our storage degrades. We forget names, misplace keys, or lose entire chunks of experience as we age. Neural implants aim to patch this flaw by acting as real-time memory coprocessors, external modules wired directly into your hippocampus. It's like giving your brain a solid-state drive upgrade. And just like a computer's drive, these neural modules could someday back up, restore, and even optimize memories for clarity and speed. Imagine sitting in a lecture, not frantically scribbling notes, but simply tagging the whole session in your brain's search bar. Later, instead of struggling to recall, you'd replay the memory in high resolution, every detail, every phrase. Think about how differently education, careers, and creativity would unfold if recall were effortless. Neuralink is one of the loudest names in this field, often criticized for hype, but undeniably groundbreaking. Their latest prototypes use thousands of ultra-thin polymer threads, each thinner than a human hair, inserted into the cortex by a surgical robot. Think of them as neural USB ports, high-bandwidth connections between your thoughts and external devices. Early demonstrations with pigs and monkeys showed live-streamed brain activity and even computer cursor control. The path to memory and intelligence augmentation starts with decoding and writing neural signals, and Neuralink is proving it can be done. Their roadmap stretches beyond medical repair into cognitive upgrades, painting a picture where human brains work seamlessly with artificial intelligence. Kernel takes a different approach. Instead of invasive implants, they've built non-invasive helmets using time-domain functional near-infrared spectroscopy, or TDF-NARS. In plain English, it's a way to scan blood oxygenation in the brain with high precision, tracking cognitive activity. Right now, that might sound like just another imaging device, but Kernel's vision is to give you a dashboard for your mind, a readout of focus, learning efficiency, and memory strength. It's like a Fitbit, but for intelligence. Imagine being able to measure your concentration before a big presentation, or see in real time how well you're absorbing new knowledge. For students, professionals, and creatives, it could be transformative. Synchron, meanwhile, is solving the implantation problem with elegance. Their device, the Stentrode, is inserted through blood vessels rather than open brain surgery. Picture it like a stent used in heart procedures, but placed in the brain's venous system. Once in place, it unfolds to record and transmit neural signals. This minimally invasive method reduces risk and opens the door for mainstream adoption. Think about it. You wouldn't need brain surgery to get a cognitive upgrade. You'd get a procedure closer to a heart catheterization, a hospital visit instead of a neurosurgical marathon. The path to widespread adoption often depends less on technological brilliance and more on accessibility, and Synchron understands that perfectly. Remember when pacemakers seemed like extreme tech? Today, millions of people carry them, living longer lives because of it. Brain implants may follow the same trajectory. What is exotic today often becomes ordinary tomorrow. The academic side of this story is equally thrilling. Research from the University of Southern California showed that implanting an artificial hippocampus model into test subjects enhanced short-term memory by up to 30%. That's not just data. That's a person remembering a list of numbers more effectively than their baseline brain allowed. It's intelligence amplification in controlled conditions. When those models get smarter, more personalized, and linked with cloud computing, you're looking at the birth of augmented cognition. Imagine the synergy of a brain that learns faster and an AI system that curates what it learns, blending organic intelligence with machine precision. If you want to follow these leaps before they hit the mainstream, subscribe, like, and turn on notifications. But let's not get carried away without checking reality. Brains are not computers in the traditional sense. Neuroplasticity, the brain's ability to adapt and change, is both an opportunity and a barrier. Yes, implants can deliver stimulation, but the brain has to integrate that data meaningfully. Too much artificial input, and it becomes noise. So the future isn't about downloading Shakespeare overnight, at least not yet. It's about extending learning curves, accelerating recall, and optimizing the way neurons already work, incremental but revolutionary over decades. Imagine retraining for a new career midlife, not by slogging through years of study, but by using neural assist systems that accelerate comprehension and memory. That's economic mobility, resilience, and personal empowerment, all powered by brain tech. If we can lift barriers to learning, entire generations can reinvent themselves more freely. Think about Alzheimer's for a moment. Today, it's one of the most devastating diseases, erasing identities piece by piece. Neural implants that reinforce memory pathways could become the most humane medical breakthrough of the century. Restoring a person's memories doesn't just improve their quality of life, it restores their sense of self. Of course, every enhancement comes with limitations. Surgery carries risk. Implants must be biocompatible to avoid scarring. Even non-invasive helmets like Kernels are limited by resolution. They measure blood flow, not actual electrical firing patterns. And beyond the technical, there's the ethical. Who gets access? If intelligence can be enhanced, will society divide into the upgraded and the left behind? Could enhancement be weaponized, with nations racing not just for nuclear arsenals but for neural superiority? These questions sound like science fiction dystopias, but they're already being raised by ethicists and regulators today. The World Economic Forum has published white papers on neuro rights, and Chile even passed a constitutional amendment protecting mental privacy. This isn't future paranoia, it's present policy. Neuro rights, the right to control your own thoughts and memories, could soon be as important as freedom of speech, but optimism deserves its spotlight. Imagine classrooms where struggling students have neural companions that tailor learning pace in real time. Imagine doctors absorbing complex diagnostic information with enhanced working memory. Imagine musicians recalling entire symphonies note for note, or engineers designing structures while visualizing every stress point simultaneously. This isn't replacing human intelligence, it's multiplying it. The possibilities stretch into creativity, problem-solving, and empathy, all boosted by neural clarity. Neural enhancements also promise a democratization of genius. History shows us that breakthroughs often come from rare minds: Einsteins, Curies, Teslas. If implants can nudge the average IQ upward by even 10%, we're talking about billions of people contributing more creativity, more problem-solving, more innovation. A world where average minds think like today's extraordinary ones could accelerate everything from curing diseases to colonizing space. Take a second to imagine the internet, but powered by minds enhanced in sync. Knowledge wouldn't just be shared, it would be directly integrated, like a global hive mind, where every individual still keeps their identity. It's not about losing individuality. It's about magnifying it in concert with billions of others. Now, timelines matter. Based on current clinical trials, Synchron expects broader rollout within 5 to 7 years for paralysis applications. Neuralink is pushing toward human trials now, with intelligence augmentation likely 1 to 2 decades out. Kernel's consumer-facing helmets are already available to researchers, and academic labs are publishing steady progress. That means the next decade isn't about if, it's about how fast. The commercial incentives are massive, and the demand is already visible in education, healthcare, and defense. But let's check expectations. Even if you could implant an enhancement today, training your brain to use it effectively would take months, maybe years. Neural learning follows the same principles as muscle training. Just as lifting weights doesn't make you instantly strong, implants won't make you instantly brilliant. The real gains will come from long-term synergy between silicon and neurons. And like exercise, it will be an ongoing practice, a lifestyle shift as much as a medical procedure. Still, the trajectory is undeniable. Look at smartphones. Within 15 years, they became extensions of our minds, offloading memory, navigation, and calculation. Brain tech is simply the next logical step. The question isn't whether humanity will augment cognition, but how we'll do it responsibly. Will we treat it as a tool for empowerment, or allow it to become another wedge between the haves and have-nots? As we near the horizon of this discussion, it's worth remembering the emotional core. Technology is never just about circuits and code. It's about people. A soldier with PTSD, finding relief through targeted neural stimulation. A child with learning disabilities, unlocking potential once hidden. A grandparent, remembering family faces with the help of implants. These stories remind us that neural enhancements aren't just tools for the privileged, they're lifelines for millions. Behind every chart, every lab breakthrough, there is a human story. And yet, curiosity should keep us restless. What happens when intelligence amplification reaches a threshold where humans think in dimensions we can't imagine today? Will we discover entirely new forms of art, science, and philosophy? Or will we redefine what it means to be human as mind and machine blur into something new? These are not just technological questions. They are spiritual and existential ones. The leap from Homo sapiens to something beyond may not come from space exploration or genetic engineering, but from wiring our thoughts directly into systems that expand them. What if the brain's true potential isn't capped at 100 billion neurons, but at the networks we create between biology and technology? And how will you feel decades from now when someone asks whether you chose to stay as you were or to expand what it means to think? Subscribe, like, and turn on notifications, because the future of intelligence is unfolding right now. This is Tech Mythos.